So the implementation of principles of bioeconomy and circular economy is very profound in the aspect of raising environmental awareness. Application of waste materials in polymer industry is quite a challenging task, but it can lead to lower energy consumption, reduced waste generation, and changes in the environmental impact that the industry has. So generally, the search for sustainable technologies that use waste materials is very important. Coffee is present in every culture around the world. The abundance of coffee consumption, following by the constantly growing population, results in large amounts of waste generated. Coffee beans annual production in the 2019-2020 crop year has exceeded 10 million metric tons, and waste from beverage consumption is almost equal to the mass obtained from coffee beans, given that coffee production doesn't have significant amounts of byproducts. So spent coffee grounds, later referred to as SEG, is the final product in coffee preparation after brewing. And it is a valuable waste material because it has significant organic compounds in its chemical structure, such as lignin, hemicellulose, cellulose, and other polysaccharides. And from the aspect of circular economy, it can be used as a filler in composite materials. Unsaturated polyester resins is a significant group of thermosetting polymers. Their global production is around 12 million metric tons a year, which makes them one of the most mass-produced polymer materials, and they can have a wide range of properties because of the many compounds used for their synthesis. Use of unsaturated polyester resins can be as pure for decorative products, or the use will be more focused on during these presentations. They can be reinforced with suitable fillers, commercially used as polymer concrete or a binding agent in different types of coatings. UPRs generally consist of two main components: unsaturated polyesters and reactive diluents. These components are generally obtained from petroleum. Commercially used reactive diluent styrene poses a potential health risk and has cancerogenic tendencies and isn't very suitable for human health. So the transitioning trend from petroleum-based raw materials to bio-based raw materials is very important, and generally transitioning to cleaner technologies. So in this paper, we synthesized a bio-based unsaturated polyester resin as a matrix in a composite material with spent coffee grounds as a bio-based filler to obtain a fully bio-based composite material. Obtaining the material consisted of the polycondensation reaction between itaconic acid, succinic acid, and propylene glycol. Obtained pre-polymer. The polycondensation reaction was conducted under nitrogen atmosphere. The temperature range was from 110 to 190 degrees Celsius. And obtained pre-polymer was cooled to 90 degrees Celsius and later diluted with dimethyl itaconate 30% with respect to the pre-polymer. It is important to note that all of these compounds can be obtained from natural resources. Before curing, SEG was sifted through 200 micron sieves and dried in an air oven at 80 degrees for 5 hours. After mixing, the mixture was poured into Teflon molds and curing was performed at 60 degrees for 24 hours, and additionally all samples were kept at 100 degrees for another 2 hours to harden. Because SEG, the composition SEG varies on the roasting and general process techniques, FTI spectroscopy was used to determine its chemical structure. In the first graph we can see The first marked area showed a white characteristic peak that correlates to vibrational group or hydroxyl group, which is present. The next area marked derives from methylene groups, and this marked area here corresponds to CC double bonds. We've also conducted FTR spectroscopy of uncured and cured UPRs, and both of them have a characteristic white peak. Before the arrows, this intense peak shows the presence of an ester bond forming, and the arrows show that during curing process, not all double CC bonds reacted. In the following figure, we see FTR spectroscopy of all obtained composite materials. We can see there is a clear trend indicating that the presence of SEG, this is the formation of ester bonds. The presence of SEG, the presence of SEG indicates that there is a growing amount of hydroxyl group in the composite materials. So later we conducted gel content analysis, which was used to assess the degree of cross-linking, and we can see that the presence of waste coffee inhibits the polymerization reaction, because there is a clear trend in lower degree of cross-linking with the uptake of our filler. Mechanical properties of obtained composite materials were examined by uniaxial tensile test. The neat UPR showed the highest break stress, and the sample with 10 weight% of waste coffee showed commercially favorable results. Samples with more coffee in them did not show favorable mechanical properties. Viscosity measurements show that there is a increase in viscosity with growing ratio of used waste coffee, and neat UPR showed Newtonian liquid behavior because there is no changes in viscosity with applied shear rate. The sample with most coffee, the green one, with 30 weight%, there is a sharp plummet in viscosity at the end of measurements that indicate that SEG forms clusters between the layers of liquid, and there is a sharp drop in viscosity, which isn't favorable for commercial use. So, to recapitulate, we examined the potential use of SEG as a filler to produce a fully bio-based composite material. FTIR spectroscopy did not reveal any significant interaction between SEG and unsaturated polyester resins. The result of gel content analysis indicated that the SEG acts as an inhibitor and lowers the degree of cross-linking. Obtained samples showed generally poor mechanical properties, except the sample with 10 weight% of waste coffee. Viscosity measurements further favored this sample, and this sample could be commercially used. So that's it. Thank you.
Thank you very much for interesting presentation. Any questions? Yes, Aleksandra.
Ću vam na srpskom ili na engleskom?
Kako hoćeš? Može.
Ajde da se vratimo na srpski. Hvala na izuzetnoj prezentaciji. Ja imam jedno pitanje. Kako modifikacija koju ste vi odradili utječe na cijenu samog proizvoda?
Evo radio? Ne biti. S obzirom da je korišćena otpadna sirovina KAFE, koja generalno ima problem sa skladištenjem, značajno snižava cenu proizvoda i poboljšava vrednost sa ekološke i ekonomske strane.
Hvala puno.
Hvala vama.